I want to change how you see light. But to do that, I have to take you on a journey. Light is unlike anything else in your life. It connects you to your friends and the deepest depths of the universe. Light makes life on our planet possible. Without it, the Earth would be a cold, lifeless husk. It impacts our language in ways that we often overlook. We shed light on questions, provide illuminating answers, and when things get too dark, there's always light relief. From art to science, light influences us in ways that we often don't see, yet deep down we understand. And I want to start with the role of light in art. Before Newton was separating white light into its constituent colors, Caravaggio and other artists like Artemisia Gentileschi were using the technique of chiaro-scuro. The contrast of bright chiaro against dark oscuro to create the illusion of depth and in some cases increased drama. It's a technique that works because it's based in reality. The image is two-dimensional, and yet your eye is so familiar with using light as a cue for location and depth that it becomes three-dimensional. And in the hands of a skillful artist, this technique can be used to create a sense of volume, intimacy, and foreboding all simultaneously. Combined with emotive themes from myth, religion, and history, these artists painted some of the most powerful art that's ever been seen. But for all the power of the stories in these images, perhaps the grandest story ever told is the one written in the light and dark of the night sky. But it's a story that's getting harder and harder for us to appreciate. Now, initially, we built cities to protect us from nature. Yet today, we blast them with light to protect us not from bears or mountain lions, but to protect us from ourselves. And let's face it, security is a very real issue. But lost in that glare are the visual cries of our true heritage, the stars. For generations, they've had a right to a dark sky. But to city dwellers, which is well over half of humanity today, it is lost. A child in Beijing, or even downtown Toronto, that's an image of Toronto right there, can see the moon and Venus, again, you can see them there, Jupiter, Mars, and perhaps a handful of stars. Their sky is an orange glow. Literally, the place where their atoms come from and will go to is lost beyond their eyes' perception. Yet for all our concerns about light pollution, which are very serious for us and other biota, I'd rather take this time to celebrate what light can tell us about the universe. And I want to start with something fun. The color of the universe. You can take the light of millions of galaxies and add them together to create a single color. It works because every atom and molecule emits light at specific frequencies. Think of them as having their own light barcodes. And when you take the light of all of the atoms and all of the stars and all of the galaxies and add it together, you get a color with an amazing name if you work at Starbucks. It's called Cosmic Latte. It even has its own hex code if the programmers are interested. Now, you could paint this on your walls, and if you did so, the poetry would be implicit, because you'd be taking atoms created in stars to put the color of the universe on your walls. And if you did that, how would you feel? Well, as any interior designer, or plenty of marketers for that matter, will tell you, color has the power to influence mood. It's even built into the English language. You see red when you're angry, feel blue when you're depressed, and we can even be green with envy of others. So given that interest, it's no surprise that there's been quite a bit of research, some good, some bad, done into the color-emotion connection. And it's uncovered that there are cultural differences too. In China, for example, red is strongly associated with happiness and good fortune. But if color can influence mood somewhat, can your mood influence how you perceive color? Well, because that question is less relevant to issues of design and marketing, for that matter, there's been less research. And the research that has been done isn't very conclusive. But a 2015 study concluded that people who feel sad have a harder time differentiating colors on the blue-yellow color line. So if you have the blues, you can't see the blues. Sounds like a great mnemonic. Well, it turns out it was wrong. The authors had to retract this study, but they're doing another one. But there are good reasons to believe that, in fact, mood can impact the perception of color. There's a long-standing hypothesis that, in fact, dopamine influences our perception of the color blue. Until now, I've separated art and science, but let's use light to bring them together. For years, animation was a laborious process of crafting plate after plate after plate. Computer animation makes that process somewhat less laborious, but nonetheless, it remains as creatively challenging as ever. And nowhere is this more evident than in the creation of visually realistic animation and images. It's especially acute in the creation of visually realistic lighting effects. And that's because every one of you in this room has an amazing sense of what's physically plausible and what isn't. You even have a part of your brain, yes you do, called the physics engine, right? That understands motion. You also implicitly understand how light reflects, be it from fur, fleece, or snow. So when it comes to making a visually accurate image, you're an incredibly tough crowd. Lighting is a physics phenomenon that has an emotional response. And if you want to light a room from a single source, you send out rays of light, like on this diagram. Now, eventually, they hit something. Do they reflect hard, like from a mirror, or get scattered, like from this carpet? Whatever happens, light fills up a room through a series of bounces and reflections. And if you have lots of bounces and reflections, things get complicated really quickly. This is the inside of the Talus Dome sculpture in Edmonton, hundreds of steel balls connected together. You can see there are so many reflections, it's incredibly complicated. And so creating realistic images in animation today is a collaboration between art and science. And I can even show you how we can build up an image from a scientific perspective. Here are 3 reflecting balls. You're immediately going to say, they're not reflecting. You're right, because we're turning off the physics of them reflecting. But what I'm going to do is put a reflection in, then another reflection, and we'll see what happens. So let's allow one bounce. You can see the other balls. Still doesn't look visually right compared to what you would expect it to look like, so let's add another bounce. It's getting more and more real each time. Try it. My wife actually broke out the Christmas baubles to try this, okay? As you do more bounces, things get more complicated. In fact, it turns out, my colleagues at TEDxMSVU tell me, humans need 9 or 10 bounces to really start believing things as plausible. That's a huge amount of computing. So if you have a more efficient way of doing it, Pixar will pay you a lot of cash, okay? But to make your mind boggle just a little bit more, you can think of the light that comes from the depths of the universe to our sky as kind of being the end point of the universe doing an animation project. Because all of those rays of light undergo essentially the same physics as we're doing right there. And if light in the real world isn't amazing enough, it's going to become even more important in our technological future. Technologists have long realized that fiber optic cables allow us to send data at higher transmission rates than you can with radio waves. You only have to look at TV ads to see how this technology is pushed. And the latest long-distance transmission rates over fiber optic cables are peaking at over 1 terabit a second. Now, to put that in perspective, that's 10,000 times what most firms will try and sell you to your home. So the future of higher data rates is definitely there as long as we can get the switching technology in place. But what about going beyond cables? What about using light to communicate generally? That may just be the future of interplanetary communication. For decades, space probes have been sent out into the depths of space and use radio waves to send information back to us. But the speed at which they can do that is fundamentally limited by the frequency of the radio waves and the amount of power behind the transmission. For example, this is the New Horizons space probe, which sent such amazing images back from Pluto. Remember the heart? Right? New Horizons sends data back at 1 to 2 kilobits a second. Let's put that in perspective. I came to Canada in 1994, a long time ago, and then people were stoked about 28K dial-up. That's 10 times what New Horizons can do now. So if you think your broadband is slow now, try being a planetary scientist. But light comes to the rescue. Light is the same electromagnetic radiation as radio waves, but with a frequency tens of thousands of times or more higher. Oscillating at around 500 terahertz, light has room to spare when it comes to sending data at higher and higher rates. But you all want to know, where's the technology now? NASA has already experimented twice with it. Once in 2013 with the Lunar Laser Communication demonstration. They beamed the equivalent of 30 HDTV signals between the Earth and the Moon. They did a follow-up to the International Space Station in 2014. But for me, the real technology demonstrator is coming in 2023. The Deep Space Optical Communications experiment will fly on the Psyche mission to an asteroid. And that will beam back data around the rate of 15 HDTV channels to an observatory in California, the Palomar Observatory. But remember, this isn't easy. Lasers are tightly focused beams. They need to be pointed accurately. And some of you are probably thinking, well, what happens if something gets in the way? You're absolutely right. Clouds are a problem, okay? But does this make you think about the search for extraterrestrial intelligence? Because we've been listening for radio waves for decades. And we're now talking about going to lasers. Should we, in fact, be looking for lasers? Well, it's not quite that simple, but people have looked, and thus far we haven't found anything. But we will keep looking. But now I've tweaked your alien interest. I want to leave you with one final thought. Light, strictly speaking, near-infrared light, may be the way that we find evidence for life on other planets. Not by searching for radio waves, as I just said, but instead searching for what we call biomarkers, molecules or atoms in the atmospheres of planets around other stars that have been put there by life. Now, this is a picture of a planet going in front of a star. The same way that atoms or molecules emit specific frequencies, they can also absorb it too. So if a planet transits in front of a star, you can see that absorption. This graph greatly over-exaggerates it. NASA always over-exaggerates things. So it's actually a tiny, tiny amount of absorption that we would see, but it's feasible to do. And oxygen is considered to be the gold standard for biomarkers. It's so reactive that any significant amount of free oxygen in the atmosphere is considered to be really strong evidence for life being on that planet. And we hope that the next generation of giant optical telescopes like this is the European Extremely Large Telescope, which ironically is being built in Chile. Long story, don't ask. You can see the cars at the front, little dots of cars. This thing is absolutely massive. It's the size of a stadium, basically. But telescopes like this should hopefully be able to detect oxygen in the atmospheres of Earth-like planets transiting across a star if that star is sufficiently close. And that could happen in your lifetimes. Think about that. And so we find ourselves back where we began, talking about how light can potentially connect life together. And whatever your passion, be it art, humanities, language, or science, make some time for light and let it take you on a journey of discovery. Because after all, you wouldn't be here without it. Thank you.